Hey guys, welcome to the video. Today I'm going to give a short introduction to exponents. Specifically, I'm going to look at some of the basic rules of exponents. Let's start though by understanding the notation, and basically using exponents is just a shorthand for multiplying one number by itself a number of times. So if I have some x to the power of n, this just means that we need to multiply x by itself n times. Here we call x the base and n the exponent, or sometimes the indice. X and n can be any sort of number. For instance, 4 to the power of 2 is just two 4s multiplied together, and 4 is the base in this instance and 2 is the exponent. We can have 3 to the power of 4, where 3 is the base and 4 is the exponent, and this just means 3 times 3 times 3 times 3, so 4 3's multiplied together. But we can use variables as well, so y to the power of 3 is just 3 y's multiplied together, where y can be any sort of number. So let's start by considering what happens when we multiply two terms with the same base together, so some x to the power of n multiplied by x to the power of m. We can think of a concrete example to help us figure it out. So say I had 4 to the power of 2 multiplied by 4 to the power of 3. Well, let's just expand those two terms. So we have 4 times 4 in the first bracket, and then multiplied by 4 times 4 times 4 in the second bracket. So we just have multiplications here, so when we open up the brackets we don't have to do anything special, and we get 5 4's multiplied together, which is 4 to the power of 5, or 4 to the power of 2 plus 3. And so this is our first rule, is that when we multiply two terms together with the same base, then this is equal to that base to the power of the two exponents added together. So in the general case, x to the power of n times x to the power of m is equal to x to the power of n plus m. Okay, so now we've done multiplications, we can do our division. So what if we had two terms, again with the same base, x to the power of n divided by x to the power of m? Okay, well, let's just look at a specific case again and see what we find. Say we had 4 to the power of 4 divided by 4 to the power of 2. Well, we can expand the term. On the numerator we have 4 times 4 times 4 times 4, and on the denominator we have 4 times 4. Let's cancel out where we can, and we're left with just 4 times 4. This is two 4's multiplied together, which is just 4 squared, or 4 to the power of 2. Note that this is actually 4 to the power of 4 minus 2. That is our numerator exponent minus our denominator exponent. So this is our second rule, and that is x to the power of n divided by x to the power of m is equal to x to the power of n minus m. Let's stay with the division though, because I think there's some interesting cases here. Say we had two terms of the same base with the same exponent and we divide them together. Well, in this case, if we had 4 to the power of 4 divided by 4 to the power of 4, if we expand it, we just get 4 times 4 times 4 times 4 over 4 times 4 times 4 times 4. Now this is quite clearly equal to 1. Now let's just apply our rule though that we found earlier about the division of exponents with like bases. And what we get is that 4 to the power of 4 divided by 4 to the power of 4 should be equal to 4 to the power of 4 minus 4, or 4 to the power of 0. This is another important rule, that is, any number to the power of 0 is just equal to 1. Great, and we can keep on going with this division because there's another interesting case that I want to show you, and that's where our denominator number has a higher indice. So let's consider the case of 4 to the power of 2 divided by 4 to the power of 4. Well, we get 4 times 4 in the numerator and 4 times 4 times 4 times 4 in the denominator. Let's cancel out where we can, and we're left with 1 divided by 4 times 4, or 1 over 4 squared. Now this again, let's just try our division rule for our exponents. 4 to the power of 2 divided by 4 to the power of 4 should just be equal to 4 to the power of 2 minus 4, which is equal to 4 to the power of negative 2. And so what we can see here is that any number raised to a negative indice is just going to be equal to 1 over the same term but with a positive indice. So x to the power of negative n is just equal to 1 over x to the power of n. Let's just think of one more instance where we have a fraction all in brackets to the power of some number. So here I have 2 divided by 4 all to the power of 4. We can expand this term, so 2 over 4 times 2 over 4 times 2 over 4 times 2 over 4. Now this just clearly is equal to 2 to the power of 4 divided by 4 to the power of 4. So this is our last rule, is that any x divided by y all to the power of n inside a bracket, well, we can just distribute that exponent through to equal x to the power of n divided by y to the power of n. Okay, I hope this helped you guys in understanding the rules of exponents. If this helped you, please like and subscribe. I hope you guys have a great day. Thanks for watching.